Good morning students, welcome to the next class. So in the last class we have started our unit 4. In that we have discussed the first continuous distribution too, that is exponential distribution. So what is an exponential distribution? You consider the time points. So the time points between the Poisson process or the Poisson point process is called as that follows the exponential distribution. Like suppose you consider any event, the time to occur that event follows the exponential distribution. So in the last class we have seen the definition, cumulative distribution function and central and non-central moments and the MGF and CGF. So today we will discuss the one topic is left out in exponential distribution, that is very important topic of the exponential distribution, that is lack of memory property of exponential distribution. So it is a very important one. So for geometric distribution also we had lack of memory property. Similarly like that for the exponential distribution also we have the lack of memory property. So where if suppose a random variable x follows the exponential distribution with the parameter theta. So for any constant, we consider a constant a greater than 0. Probability of y less than or equals to x given x greater than or equals to a. That means the conditional probability should be equals to p of x less than or equals to x. So we know p of x less than or equals to x means it is a distribution function. So in the last class we have derived this value already. So for all x, where what is the y value we consider? Y is nothing but x minus a. So now we need to prove this one. So coming to the proof, first write down, it is given that x follows the exponential distribution with the parameter theta, then its PDF is given as, so what is the PDF for the exponential distribution? F of x equals to theta into e power minus theta x for x greater than or equals to 0. So now, if you consider what we have to prove this equation, so if you consider the RHS probability of x less than or equals to x. So this is the distribution function, right? So in the last class also I have derived the distribution function. So your upper limit will be x, lower limit will be 0. So if you do the integration for this, you get this value as 1 minus e power minus theta x. So I have already derived this value in the last class, so I am writing here directly. So while writing the notes, you copy that derivation here. So keep this as equation 1. So now we have to find the RHS value. So consider probability of y less than or equals to x given x greater than or equals to a. This is a conditional distribution. So what will be writing? Probability of a given b. How will you write? A probability of a intersection b, that is y less than or equals to x intersection x greater than or equals to a divided by p of b. So what does p of b means? Probability of x greater than or equals to a. So now we have to find these values. So here what is y value? Y means x minus a, right? So probability of x minus a less than or equals to x intersection x greater than or equals to a divided by denominator you write as this x greater than or equals to a. So now you have to write the intersection term. dx. So what is f of x? Which is equals to integral over a to x plus a theta into e power minus theta x dx. So here theta is constant. Integration of e power minus theta x is e power minus theta x divided by minus theta within the limits a to x plus a. So theta and theta gets cancelled. Now apply the limits, that is upper limit minus lower limit, which is equals to minus of e power minus theta into upper limit is x plus a minus lower limit e power minus theta, lower limit is a. Now the same value, this can be written as minus into e power minus theta x into e power minus theta x into e power minus theta a. E power minus theta a into e power minus theta x into e power minus theta x. Yes, here we have minus. Outside also you have minus, right? So multiply that minus inside. Let's copy it in here first. So if you multiply minus inside, you will be getting e power minus theta a minus e power minus theta x into e power minus theta a. So from these two terms, you can take e power minus theta a common. So you get 1 minus e power minus theta x. So this you put as equation 3. So which value it is? Probability of a less than or equals to x less than or equals to x plus a. Now consider the denominator. Probability of x greater than or equals to a. So probability of x greater than or equals to a means the lower limit will be a and the upper limit will be infinity. So integral over a to, for exponential distribution, the upper limit is infinity. F of x dx, which is equals to integral over a to infinity. F of x theta into e power minus theta x dx. Here theta is constant. Integration of e power theta x is e power theta x by minus theta. Theta and theta gets cancelled within the limits a to infinity. Now apply the limits. Minus into e power minus theta into infinity minus of e power minus theta a. So now multiply minus inside. So you will be getting e power minus theta a minus e power theta e power infinity. So what is the value of e power infinity? E power infinity is 0. So this value equals to e power minus theta a. So now this we keep as equation 4. So substitute 3 and 4 in 2. So this is our equation 2. In this we will substitute the equation 3 and equation 4. So this value will be equals to, so which value it is? Probability of y less than or equals to x given x less than or equals to x. Y less than or equals to x, x greater than or equals to a. Yes, this value equals to, substitute the values. What is the numerator value? Numerator value is e power minus theta a into 1 minus e power minus theta x divided by denominator value e power minus theta a. So these two values get cancelled. So this value is equals to 1 minus e power minus theta x. So if you observe, what is here for the gamma distribution of second kind is given as f of x is equals to a power lambda divided by gamma of lambda into e power minus ax into x power lambda minus 1, where x lies between 0 to infinity. That means x takes only the non-negative values. So random variable x values lies between 0 to 1, and your parameters a comma lambda will be always greater than 0. So 0 otherwise. So this is the gamma distribution definition. So suppose if any distribution is, suppose if any random variable x is said to follow the gamma distribution, how we notate it is x follows. What is the symbol for gamma? We write gamma like this, gamma with the parameters a comma lambda. So you denote like this. So here whatever the gamma of lambda you have, so this is, the symbol is gamma, even this is also gamma, one is a capital letter and another is a small letter. So whatever the value you have this one, gamma of lambda. So this gamma of lambda is called as the gamma function. Gamma function. And whatever this value you have, that is gamma of a comma lambda, this is called as the gamma integral. Sorry, gamma distribution. Okay, this is gamma distribution. So that means we are saying it follows a distribution with parameters we are writing. So this gamma of a comma lambda is called gamma distribution. And suppose if we write gamma of lambda equals any constant, then it is called as a gamma function. So we know what is the value of gamma of lambda? Lambda minus 1 into gamma of lambda minus 1. So for this gamma distribution, first we have to know about one gamma integral. So the gamma integral here is given as, the gamma integral is given as, so same like the formulas, we will be writing formulas in the different steps. So in the same way, here also e power minus ax. So here also ax, sorry, e power minus ax. So the parameter is a, right? So e power minus ax. So here what is the value of lambda? Lambda equals to r plus lambda, and in place of a we have a z. So substitute in this formula, mu r dash is equals to a power lambda by gamma of lambda into the gamma of lambda plus r, or you can write r plus lambda also. Anything is same, right? So by a power lambda. So here if you observe a power lambda gets cancelled. Therefore, mu r dash is equals to gamma of lambda plus 1 by gamma of lambda plus r. So now we have to substitute different values of r and find out the 4 non-central moments. Once again, here you have a power lambda. So a power lambda means a power lambda plus r. In place of lambda we have lambda plus r. So a power lambda cancel means here we have a power r. So sorry, I did not write this value before step. A power lambda plus r can be written as a power lambda into a power r. So from this a power r cancel. A power lambda cancel means a power r will be left out. So therefore, what is the mu r dash value? Gamma of lambda plus r divided by gamma of lambda into a power r. So now we substitute the different values of the r. So put r equals to 1. So by putting r equals to 1, mu1 dash, that is your mean value, equals to gamma of lambda plus 1 divided by gamma of lambda into a power 1. So we have the formula of gamma of lambda. So what we get? Lambda minus 1. So here lambda plus 1 minus 1 into gamma of lambda plus 1 minus 1 divided by gamma of lambda into a. Now simplify this one. So mu1 dash is equals to lambda plus 1 minus 1 cancel. So lambda into gamma of again lambda plus 1 minus 1 cancel. So gamma of lambda by into a. So gamma of lambda cancel. Mu1 dash equals to lambda by a, which is the mean of the gamma distribution second gap. Now similarly put r equals to 2. So if I put r equals to 2, I get mu2 dash is equals to gamma of lambda plus 2 divided by gamma of lambda into a square. So expand this term, lambda plus 2 minus 1 into gamma of lambda plus 2 minus 1 divided by gamma of lambda into a square. So lambda plus 2 minus 1 is lambda plus 1 into gamma of lambda plus 1 divided by gamma of lambda into a square. So this is equals to again lambda plus 1. Here gamma of lambda plus means lambda plus 1 minus 1 into gamma of lambda plus 1 minus 1 divided by gamma of lambda into a power 2. So here gamma of lambda plus 1 minus 1 cancel means we have gamma of lambda and gamma of lambda gets cancelled. Therefore Similarly, what is the mu4 dash value we are going to get? Lambda plus 3 into lambda plus 2 into lambda plus 1 into lambda divided by a power 4. So find all the non-central moments. So after finding non-central moments, next we find the central moments. Now the central moments. So now the central moments. So we know the first central moment mu1 equals to 0. Next mu2 equals to mu2 dash minus mu1 dash whole square. So what is mu2 dash value? Lambda into lambda plus 1 by a square minus mu1 dash value is lambda by a whole square. Now simplify this one. Lambda into lambda, it is lambda square by a square plus lambda into 1 is lambda by a square minus this whole square can be written as lambda square by a square. So plus lambda square by a square minus lambda square by a square both gets cancelled. Therefore mu2 equals to lambda by a square, which is the variance of the gamma distribution. So now we will find the next mu3 value. mu3 equals to mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash whole cube. So substitute all the values. First mu3 dash value, that is lambda into lambda plus 1 into lambda plus 2 divided by a cube minus 3 into lambda plus 1 by a square into lambda by a plus 2 into lambda by a whole cube. So now we will simplify this one. So if you observe here, the LCM for all the values is a, the denominator is a cube. So LCM you will be getting a cube only. Now simplify this one. Lambda square plus lambda into lambda plus 2 minus 3 into lambda square into lambda plus 1. So lambda square into lambda, lambda cube, 3 into lambda cube plus lambda into 1 into lambda, lambda square plus 2 into lambda cube. So now simplify this one. Lambda square into lambda, lambda cube plus 2 lambda square plus lambda square plus 2 lambda minus 3 lambda cube minus 3 lambda square plus 2 lambda cube divided by a cube. So now observe the lambda cube terms. Lambda cube plus 2 lambda cube. It is plus 3 lambda cube minus 3 lambda cube. So this value will be cancelled. So lambda cube minus 3 lambda cube plus 2 lambda. Cancel. Next come to squares. 2 lambda square plus lambda square is 3 lambda square. So 3 lambda square minus 3 lambda square. This value also cancelled. So left out value is 2 lambda itself. So value equals to mu3 equals to 2 lambda by a cube. Now similarly find out the mu4 value. So if you know how to do the LCM and everything, it will be very easy. Mu4 equals to mu4 dash minus 4 mu3 dash mu1 dash plus 6 mu2 dash mu1 dash square plus 3 mu1 dash minus 3 mu1 dash power 4. power 6, a power 6 gets cancelled. Lambda and lambda gets cancelled. This is equals to 4 into lambda. So we know that lambda value is, here lambda cube you have here. This is cube for all the terms. So cube here square and one value gets cancelled. So the value is 4 by lambda. So beta 1, that is coefficient of skewness, is given as 4 by lambda. So since we know that this lambda is a positive value, so since it is a positive value, so this beta 1 value is greater than or equals to 0. So it is a positively skewed distribution. Similarly, find the coefficient of kurtosis, that is beta 2, which is equals to mu 4 by mu 2 square. Substitute the values, we get the beta 2 value as 3 plus 6 by lambda. So it is greater than 3. So whenever beta 2 value is greater than 3, it is a leptokurtic curve. So gamma distribution of second kind, it is a positively skewed distribution with a leptokurtic curve. So the remaining topics, that is MGF and the remaining